As we did with 2 degrees of freedom, we are going to be able to get closed form solutions for the steady state behavior when we have simple harmonic forcing in our multi-degree of freedom systems. And the process is going to be pretty much identical to what we did for 2 degrees of freedom. So if we have an equation of motion in matrix form, where we have a stiffness matrix, a damping matrix, and a mass matrix, and as our right-hand side is going to be simple harmonic forcing, we're going to take the same steps we did for 2 degrees of freedom. But we're going to have the same restriction that on the right-hand side, every degree of freedom needs to be affected by maybe a different amplitude, but the same frequency and phase, cosine or sine function. So we're going to make the impedance matrix the same way we did for the 2 degree of freedom systems, using those 3 matrices we have from the equation of motion, and we're going to find the steady state solution the same way, that we're going to find some amplitude vector x, and at steady state, all of the degrees of freedom are going to be oscillating at the driving frequency. And x is going to be found the same way. We're going to take that impedance matrix and take its inverse and multiply it by the f vector, the amplitude of the forcing. So the only difference we have here from the 2 degree of freedom systems is that z and f are larger matrices, and x is going to be a larger vector. And we're going to see the same complication in z when we have a non-zero damping matrix, C. We're going to see that z is going to have complex values. So therefore x is also going to have complex values, but we're going to address this the same way we did with 2 degrees of freedom, is we're going to take x from its Cartesian form with a real part and an imaginary part, and we're going to rewrite it in its polar form with an amplitude and an angle. And now we just have to do that for every degree of freedom that we have. So we're going to be able to find its amplitude by taking the absolute value of each entry in x, and we're going to be able to find its phase by using angle, or finding the angle it makes in the complex plane. So then, just like we saw for 2 degree of freedom systems, the steady state is going to be the amplitude of each entry in x times cosine of the driving frequency times time, plus then the phase that we're going to get from the angle in each value of x.